Phosphorylation and epigenetics. Discovery of the phosphorylation of tyrosine. There are many important discoveries that lead us to where we are today with our understanding of phosphorylation. One important discovery was tyrosine phosphorylation in 1979. Like all other types of protein phosphorylation, tyrosine phosphorylation regulates proteins in many ways, such as controlling cell growth and signaling pathways. Primarily, phosphotyrosine serves as a docking site that promotes the interaction between a tyrosine phosphorylation protein and another that contains a phosphotyrosine binding SH2 or PTB domain. These interactions are essential for signal transduction downstream from receptor tyrosine kinases on the cell surface. In 1979, in Tony Hunter's lab, the first discovery of protein tyrosine phosphorylation was made. Tony found a phosphorylating tyrosine in the immunoprecipitates of an animal tumor virus transforming protein polyoma T antigen. The virus studied was the rarosarcoma virus VSRC protein. In the next years, Hunter and other scientists demonstrated that both the rarosarcoma virus transforming protein and epidermal growth factor receptor have intrinsic tyrosine activity. These findings prompted researchers in the 1980s to demonstrate the intrinsic tyrosine phosphorylation activity of additional growth factors. By this time, researchers realized that ligand-induced tyrosine phosphorylation can be a major and common mechanism for the transmission of signals across the plasma membrane. So tyrosine was particularly difficult to identify, and why is this? For instance, serine and threonine activities were first identified in 1954, and Phoebus Levine reported the synthesis of the phosphorylation of tyrosine in 1933. However, phosphorylation of tyrosine in proteins was not described until nearly 25 years later. This is because, unlike serine and threonine phosphorylations, most tyrosine phosphorylations are short-lived. This is due to the presence of extremely active phosphotyrosine-specific phosphatases that rapidly dephosphorylate any phosphotyrosine residue that is not protected through binding to an SH2 or PTB domain or through an intermolecular interaction. Thus, tyrosine phosphorylation is important as it is a mediator of the signaling cascade and is observed in diverse biological processes. Understanding tyrosine phosphorylation helps us understand diseases and target tyrosine kinases, such as cancer.
Created using Powtoon.